So some of you might question, why can't we just analyze a malware behavior, do static or dynamic analysis, and from that we will learn the attack pattern of that specific threat vector. The point here is that not everybody has access, or not everybody has been infected by that malware already. So what we'd want to share with the community is that given somebody was infected, or some organization or computer was infected by an attack vector, what was the pattern that they observed? And it might not be the same for every other organization. So we want to collect those attack patterns across various organizations and see if there is similarity in any of those patterns within my organization. Therefore, attack patterns are important to know in advance. So that's reason number one why we need attack patterns. Also because what wasn't possible 10 years ago is possible now. There is unprecedented growth of publicly available information and means of accessing that information. So websites, forums, social media, and Twitter. There's a lot of free data out there that can be used to collect attack patterns. Next slide. Next. So taking the same example forward, Cerberus, and keeping in mind that the threat report, the snapshot that I showed you, if we extract a small paragraph from that threat report, I will not go into what exactly our model, how it works. That is for you to read in the research paper. What I'm going to show you is that for this kind of an unstructured text, we were able to use open source tools to extract specific information from that text. For example, Android here belongs to a class operating system, and I'll tell you why am I talking operating system, application, malware types, and nothing beyond that. So there are some specific classes that we have identified and designed it in ontology, and that ontology has been created by reading several such threat reports, as well as by learning about existing ontologies. So we have identified common classes present in a threat report, and using those common classes, we build a named entity extraction tools, which is able to extract specific key phrases after running a tokenizer across the entire document, and also established the relationship between each of these classes. So for example, once our NER model runs on a document, how does it look like? So the entity head, relationship, and an entity tail, this is a triple because this has three pieces of information. Cerberus is at the center of it because we are talking about Cerberus. Cerberus targets Android, which is a form of class operating system. All this information was extracted from the threat report automatically. All right. And I also mentioned here the name of the class, like Spain is a type of location. Application, this is the name of the application on Google Play, and so on and so forth. So this is static information, right? We are talking about attack patterns. Steal victims' bank account credentials is a form of an attack pattern that we were able to extract from the threat report with very high accuracy. When we have collected all of this information using our NLP tools, what we do with it is we form a graph. So this is this very, very tiny snapshot for the purpose of this presentation. At the center is Cerberus, and at the edges are these other objects or these instances of the classes. And in between these edges is basically, this is the relationship between them. Next slide, please. So taking this forward, what it basically means is that the triple that I talked about becomes Cerberus uses steal bag account credentials. So we were able to extract all the attack patterns in a report, Imagine we have 50 such threat reports about Cerberus. We are able to pretty much capture the entire timeline of this malware. This is all using our framework ladder. And then once we were able to extract all of that, we were also able to map the attack pattern to MITRE attack framework. So this ID is the MITRE attack ID. So for those familiar, you probably can recognize these IDs. For those unfamiliar, MITRE attack framework is able, basically gives you IDs for all possible attack patterns in enterprise networks, mobile, and everything and anything under the sun. Next slide. And I'll show you why do we need to map it to MITRE attack pattern IDs. So what is the benefit to SOC analysts in what I just did? What I just showed you is our goal is to aid SOC analysts in threat hunting and protection against APT campaigns. And how? I just showed you how we were able to automate attack pattern extraction. What we are also able to do is to correlate attack pattern extraction from the reports with kernel logs that can pinpoint an attacker's activities. Next slide. So what that means is that it's part of another research is that we were able to extract patterns from threat logs and map them to the attack patterns in the CTI. And that mapping needs to be accurate, and for that we were able to use the MITRE attack pattern IDs. So MITRE attack pattern ID in a CTI and the MITRE attack pattern ID in a log, if they can be mapped, that can give you an idea about an emerging threat in your system logs, even if you're not able to see the entire attack present in your logs. So the CTI format has been very useful, and how CTI is usually read by a SOC analyst manually and not in an automated way is that you get the report, you study about a malware or any kind of threat that you want to study, and what is the prevalent technique, trend, and threat, and that's what we were able to automate. And also learn about the detection, also learn about how to detect, mitigate, and simulate specific threats and techniques. And finally, map ideas, guidance, and priorities to their security measures and general strategy. So if we are able to do this in an automated, if I wouldn't say fully automated yet, but even if it's in a semi-automated way, threat reports can be, or threat intelligence can be very useful. Next slide. So I talked about the ontology. This is the ontology. This is part of another research paper, not the one submitted to this workshop. So this is the ontology that we created and the relationships between them. This is abstract enough and not too detailed that you will get, that the analyst will get overwhelmed by the information. So each one of these, the one which has an arrow, has subclasses like indicator would have IP addresses, email, hashes, and so on and so forth. So this is just a snapshot of the ontology. There's more to it. So these are the 10 classes that we used to extract tokens from threat reports and again convert them into triples, entity, head, relationship, and tail, which kind of codifies a statement into an RDF format. And once we have plenty of those RDF formatted triples, we can generate a graph out of it, which the SOC analyst can query. So I'm going to show you how to query that graph. So triples aggregated in the graph are called threat intelligence knowledge graph. This was generated using only 25 threat reports. This is an actual graph. We didn't just make it up. The red ones, the orange ones are basically the malware, and all the other nodes and the connected edges are relationship and the information about that node. So I won't go into the details of how did we crawl web pages, how did we extract IOCs. This is done and dusted. Everybody knows how to do that. The last part I'm interested in is talking about the attack patterns. So we have these sentences. I guess you probably are interested in how did we extract those attack patterns, and what kind of a model did we build to extract those attack patterns. So attack patterns are basically, you have all of that text that I just went through, and only parts of these will have a description of the attack. So what we did was we broke down that task of identifying attack patterns and classifying them into 3 subtasks: relevant sentence extraction, which sentence actually has an attack pattern versus which ones do not, and then attack phrase extraction from the sentence. Not the entire sentence will have a phrase or an attack pattern, so extracting just the relevant part of it, and then finally mapping MITRE attack ID to it. So the first one was the relevant sentence extraction. We made that into a binary classification, and to train the binary classifier, what we did was MITRE attack patterns has the title of the attack pattern as well as the description. So we trained our classifier on using those descriptions. We also had a lot of annotated data, which our students did over several months, prepared over several months, and using the hand annotated data as well as data from MITRE, we trained our classifier, using which it was able to identify whether a sentence has an attack pattern or not. Next sentence. And similarly for attack phase extraction, from within the sentence, whether it was an attack phrase or not, which verb was the starting verb for the attack phrase, we were able to train another BERT-based classifier. Finally, mapping it to the MITRE ID, we adopted a semantic similarity-based approach, and the distance between so what we created was a list of all potential threat patterns, attack patterns from MITRE. We created those, the distance between those as well as the ones which were identified as having attack patterns, and the similarity score was measured between the two. The ones which were closest to an existing attack pattern was what it really was, and therefore we were able to get the MITRE attack ID. We were also able to identify new attack patterns which are not present in MITRE attack also. So how will a SOC analyst use all of this information is the SOC analyst can use any of the threat reports. You don't even have to clean it up, just any PDF format, convert it to text, ingest it into our existing model, and what you will get is a triple. The response will also be in RDF format. So the triple will be the name of the malware, the relationship, as well as the ID of the MITRE attack pattern that it has identified in the threat report. So these are the results. You are welcome to go over them. They are in the paper. So this is about the entity extraction. Entity extraction meaning that all the IOCs and the attack patterns that we extracted. The bold ones are what my students worked on. Next one. And similarly for attack phrase extraction and sentence extraction. So sorry, sentence extraction and attack phrase extraction. These are the results. Going forward, so the biggest challenge that we have is obviously the patchy quality of CTI. We have overcome it to a very large degree, but we don't have a lot of cyber threat intelligence reports. We are aware that these are sold for a pretty cost. But if we can find collaborations, then we can, it's probably in the order of 10 to 50K, maybe more. Can you go back to the previous one? And then the next one I already mentioned is the parallel research of mapping external threat intelligence to internal threat intelligence. We have been able to accomplish this as well by using Sigma rules and finding those logs where there was an evidence of attack, but this hasn't been scaled yet. We were able to do it at a programmatic level, not at scale. And obviously data to test results, which is possible only if we have more CTI in hand and access to internal logs. That brings me to the end of my presentation.
So my third half, how many dominate knows it was it's out of reactive stuff, but how much of it is this preparatory phase of an attack?
So yes, MITRE attack patterns. What do you mean by reactive?
It's like the ongoing attack. That's all.
I see.
This would capture more the reconnaissance phase I spoke about that.
No, it will be able to detect any kind, not just reconnaissance, but so the attack pattern can belong to any of the stages, any of the 7 stages, I believe. There are 7 of those. So we were able to extract threat attack patterns for all the stages. So I think there are 3 levels: tactics, techniques, and procedures. So procedure goes to the code level. My research hasn't gone to that level yet, but at tactics and techniques, both of the levels, we were able to create attack patterns and map them to MITRE attack pattern. And reconnaissance is one of the tactics at tactics level. Yeah, so it's just about training your data, the ample number of sentences, which can map to each of those tactics and techniques.